Welcome to the Gardien Group Podcast Series. The Gardien Group, providing extraordinary solutions to today's exceptional problems.
Hello, podcast fans. Welcome to another edition of the Gardien Podcast Series. I'm Todd Kolmodin, your host, along with Rick Meraw. Today, we're going to talk about testing as it pertains to high and low volume of product. Basically, the first thing I want to talk about is what we're talking about when we're talking volumes. In ET, or electrical test, basically two common scenarios of testing, low and high volume. Today, we're going to discuss both of them. Low volume, as seen in the North Americas, is prototypes and critical time to markets, where higher volumes are a lot of the commercial product that we see everyday life, cell phones, all that type of computers and all that, where a lot of that commercial type stuff is not done here in the U.S. So, Rick, welcome as usual. Glad to have you aboard.
Thank you, Todd. Today's topic's a very interesting one, especially when we think about the North American, European markets and compare them to the Asian markets. As far as volume, we still today get a lot of the high volume parts only from Asia.
Exactly. And while you're kind of jumping into that, I mean, talking about volumes in the North Americas versus Asia, I know you've had a lot more experience over there in Asia, seeing the manufacturing plants. I had one trip over there where I got to see some of the higher volume plants as compared to when someone says volume, when they talk about the North Americas versus Asia. I mean, what type of order of magnitude are we talking difference that would be an eye opener to people?
Well, Todd, that's a very good question. Now, sometimes I know I grew up in the North American market, so high volume at one point was like 1,000 pieces in an order, or maybe up to 10,000. But some of these high volume part numbers, there's plants that are dedicated to them where they make millions of the same board, which really you can streamline. But that's very, very seldom done these days. So a lot of high volume is between 10,000 and 100,000 pieces.
Okay. I know here in the U.S., I mean, things are changing. We're trying to get more of the commercial market back, but I'll take the moment. I'll kind of talk about low volume. When we talk in Americas, low volume, like Rick said, is, up to, 1,000 pieces is considered high volume for our markets in the North Americas. But it's based on factory capacity, their order niche, and many other factors. Quick turns shops usually fit into this category. And when we're testing on low volume, one of the best that we think options for that is use flying probe equipment. The flying probers are low cost as far as comparing to dedicated fixtures and fixture testers. They're lower cost. If you have multiple jobs you're going to run, you can switch jobs really quickly. The setup time is slow. If you have to modify a program, you can do that, send that information to your CAM center. They change the program or fix the program, and you're back running again, with sometimes in less than an hour, depending on the capacity of the CAM center. Flying probes can be upgraded to higher volume machines, just by adding automation. And we talked about that in a earlier podcast this year with Holger Kern. We talked about some of the Kaima equipment, and we talked about also the Gardien equipment where we can add load and unload functions. The other option that's really cost effective for flying probes is the ability to do multiple test options from the same platform. And what I mean by that is testing the standard opens and shorts, but if you have some buried passives, or if you need some high pot testing done, or even, inductance, this can all be done on the flying probe at one time, not having to change the program or use multiple programs. That all can be done fast and efficiently on the same machine. Plus, you have a faster ROI. Your investment cost is lower, and so as you run your higher dollar amount type product on there and you recover, your return on that investment is quite a bit faster than on some of the more expensive fixture testers. One couple of disadvantages though with that. Remember, we're talking, lower volume. Your speed versus the fixture tester is not as great. We don't have the full parametric test. These use what we've called and talked about in the past, the signature analysis or indirect test and adjacency testing, which is a limitation when you talk that against fixture testers. And then we do have some of those limitations, like I mentioned, the parametrics, and also some other limitations due to customer industry specifications. Some require direct test, which means some of the speed advantages of the flying probers can't be used. So your same board tests the same amount of time every time the board's on there. But overall, for lower volume, your flying probe is definitely probably your most cost-effective option with that. So, and then the other option is high volume, and in the North Americas, higher volume. We do recommend the fixture testers. I mean, you can still use flying probes with automation, but I'm going to let Rick talk a little bit more about high volume testing and break it down here in the North Americas.
Yeah, yeah, Todd, I just wanted to add in, the flying probes are getting faster. They're testing faster than what they did a few years back. But you still can't compare to if you have a fixture ready and there's not much setup time, if the machines are well maintained and etc. You can put a fixture on in a few minutes and then start testing and start getting green lights, pass boards off the right away. And you still are only going to test in a few seconds. Compared to a flying probe cycle for a single piece it could be a few seconds on lower test point counts, but on higher test point counts, no, you're going to be in the minutes range usually. So when you're using a fixture tester, there's no way you're in minutes range most of the time. Now, that being said, we have seen some product where we've had many, like over 100,000 test points. And yes, that takes over a minute to test, but that's also going to take hours on the flying probe to test. So,
well,
high
you
volume.
Sorry, Rick, to interrupt there, but that's a great point you just brought up there when we're talking flying probe testing and when we have smaller point counts. But I didn't mention that in the disadvantages as the test points get extremely high on the probers, especially if you're not allowed to do, indirect test. Your time to test disadvantage gets a lot greater. That's a good point I forgot to make.
Yeah, if we're doing class 3 or class IPC class 9252 class C product, we're testing everything. Everything open and mass basically is being tested. So obviously you're going to have a higher and higher test point count. And once again, a test point count is any copper extruding from the surface mount or extruding from the mass material in this case, whether it can be connected or have no connections, as we discussed in one of the previous podcasts, one of the first podcasts, I believe, Todd.
Yeah.
So some of the advantages of high volume, as I already alluded to, is that it can test very quickly. It's faster for higher point count jobs if you automate it. Now, because if you think about automating a flying probe machine, you put a couple hundred panels on there. Let's say you put a couple hundred panels on a flying probe machine, and it takes maybe 12 hours to finish. But if you put a couple hundred panels on a fixture machine, a grid tester, it could take only half an hour to finish those. It all depends on what speed you're running at. So you have to have a continuous flow of product going through this machine because it's high volume. And so you're not going to be putting in batches of 50 because 50 is done in like 15 minutes or so. So you need to be able to quickly change over the stack. So most automated volume testers, whether it's a grid or a dedicated tester, are going to have multiple stacks where you can load in and unload product, usually in a couple hundred at a time, because a couple hundred usually takes about 30 minutes to test. But there again, another advantage is it's a full parametric test. It's a robust fixture design. It's very high speed compared to flying probe.
I know when you were talking about the Rick, when you're talking about effectively using the machine, it's the main or operating cost per hour. If you're spending most of your time running 50 board lots, you're spending all your time changing orders rather than letting the machine do what you're paying it to do.
You're very true there, Todd. Very true. Some of the disadvantages on a fixture tester is, okay, there's a higher cost, but if you divide this cost over the cost per test, I'm sure overall it's still lower cost compared to a flying probe tester. So you have a fixture and you have maintenance of a some sort of fixture machine, whether it's grid or dedicated. And if you're using a universal grid, we know that they have a higher cost of maintenance compared to flying probe, just because they have so many test points in there. If you have a flying probe, maybe has 16 heads, 4 heads, 8 heads, those are your test points, available testing devices. But in a fixture tester, it depends on what you're doing. You could have 200,000 test points. You can have a smaller grid in octal density with only 100,000 test points, but that's still 100,000 contact points that you need to take care of and maintain. So definitely there is a higher maintenance cost on the fixture testers. And yeah, there's going to be a little bit longer setup time because you have to put the jigs on the top, the bottom, or however you want to set the machine up. And the programming time is a little bit more, and tooling is a little bit more thought out. Let's say you have to either make a dedicated fixture or you have to make a universal fixture, and you have to take into compensation the point on the universal grid to the point on the PCB board. So you're going to have some sort of deflection in there. There's multiple different schemes of doing this, but most of the time it's kind of like a leaning pin. So that has to be thought out. Sure, we have algorithms for that, but it still takes longer time to do it. And then you have to go to drilling, and then you have to assemble it, and you have to store the tool. So it's like having a tool. You have to store it, maintain it. So there is a little bit of higher cost, but when you add all the costs together, depending what kind of product you're doing, if you're doing high volume, then the whole cost added in together, it still works out to be least expensive to test it on a fixture than it does on a flying probe. But you need to have some know-how in how to do that.
Very good. You mentioned something, and for those that might be joining us and haven't talked or listened to some of our earlier stuff where we talked about fixturing a little bit, you mentioned the universal fixture and a dedicated fixture. Can you kind of just give people a quick update of what you mean by those differences?
A universal fixture, Todd, is the machine has fixed spacing, whether it's a 50 mil spacing from point A to point B in a line. So there's 50 mils between the center of each point, and it continues across what we call a bed of the machine in both the X and the Y direction. So that becomes the available test points or universal grid in that particular machine. But the PCB itself isn't going to have the same sort of 50 mil layout. So then what happens is you need to deflect the current from the base of the machine into the PCB surface mount pads or through hole pads. So you have a test pin that's on an angle that does this. And that's very low cost because you're using a test pin and you're drilling a bunch of plates. So it's not as high of cost for a dedicated. Now, a dedicated machine maybe only has 20,000 test points, whereas a universal machine maybe has 100,000 or a couple 100,000 available test points. So the dedicated machines definitely are a low-cost fixture tester, but the fixture themselves, dedicated means you use a wire. Basically, it comes off the scan cards of the dedicated tester into some sort of connector, most times 64 or 124 bit connector or point connector. And then that connector now has to interface with the fixture. So you take every test point you put a test point on some sort of small pin that has a receptacle attached to it and a wire that goes back to the 64 pin connector. And that 64 pin connector connects to the dedicated machine and goes to the scan card to perform the test. Now you repeat this process for every single test point. So if you have 10,000 test points in your PCB, you're going to have 10,000 wires in there. So it can be done. The fixtures are a lot more expensive than a universal fixture, and the machines themselves, because you can use the test point wherever need be. The dedicated testers are a lot less expensive, but you're looking like a 10,000 point fixture. Let's say it cost you $1.50 for a wire or $1 a wire. So it's either $10,000 or $15,000 for that fixture. So you want to make sure that you have some significant volume. And what's kind of unique with a dedicated fixture is you don't have to worry about any angles or deflecting down. You can put the test pin directly underneath, providing that you get the small enough socket, or there's different tricks that people do. I know that in some of our operations, we use something called a hybrid. So we use like a 2-inch fixture, which connects to the wired base, which then connects to the machine 64-pin connector. It sounds like a lot of connection points, but it's a little bit more cost efficient than having to put a receptacle in a wire. So a receptacle would hold some sort of spring-loaded pin and go from there. Yeah, fixturing is more complex, but once you have it set up and you know what you're doing, or you have a vendor that knows what they're doing, then it's relatively easy for you to set up the machine and manage. You need to manage the tool. It's like anything else. When you're building a printed circuit board, you need to manage. If you're still having artwork and things like that to image your boards, you need to manage that, right? It needs to be ready before you actually want to take the cores and image them. So it's part of the management process, but most PCB shops are good at managing anyway because they manage their workflows with some sort of production control software.
Thank you for that updated explanation on universal versus dedicated, and can't say that enough on the dedicated stuff. You want to, like Rick said, make sure that you're going to have some high volume and that your revision is stable, because like you said, $10,000 fixtures, and some engineer wants to change one pad or two pads on the board. This could be extremely expensive to retool that. Thank you very much, Rick. So looking at the crystal ball, as we look into the future, Rick and I are just kind of talk back and forth a little bit about what's going to happen for us in the North Americas. Of course, we want more activity in the North Americas, and we'd like to see some of that higher volume stuff come back, and especially with the pandemic and all the things that have been going on here worldwide. We've got shortages of chips and electronic devices, and we'd like to see some of this, get back here to the U.S. And I know, plans are to try to do that. What are your thoughts, Rick, on the future?
Well, I think the North America, even the European market, will see some volume come back as people begin to invest in more automated PCB manufacturing facilities. Right now, we all know that the bulk of there's a few shops in North America that can make high volume, but not a lot of them. This volume may come back to the North American market as we see some shops automate, become more capital expenditures. So when we see this occur, the volume in theory could go up in the North American and European markets. But we would need to be ready for what type of electrical test, even quality assurance equipment that we would need for this product. Just like with a fully automatic shop, we see some shops already 2 or 3 developing, and a lot of people are working on automation. They have technicians and engineers dedicated to automation in the current facilities. But we also see some plants that are fully automated, or so-called fully automated from start to finish. But they all stop basically at electrical test, whether you have an automatic flying probe or electrical test or some sort of QC process, they're all stopping there. But I think the volume, Todd, overall will go up a little in North America in the next 5 years, I would estimate.
I totally agree. I mean, volume in the U.S. right now, I don't, like you said, I don't know if we'll ever meet the consumer volume that is processed in Asia. I just don't know right now if we compete. It could be some time before, we get there. But I know, like you said, there's a lot of automation starting to go on, and we did a podcast a while back on process development, and where Rick just mentioned, it goes automated gangbusters until it gets to ET. Well, there's some things that you can do that we've talked about where you can kind of get some ET involved in the manufacturing process upline, where you can actually find some defects that may scrap the board clear when you wait all the way down to final board ET. So getting the ET engineering guys involved when you're putting an automation process on your lines, sometimes that's a great thing. I would say always a great thing to get ET involved as well, because they can be a lot of times the black hole, as some say, of the manufacturing process. It disappears into ET and no one knows what happens after that. But anyway, flying probe, as we talked about, probably one of the best options for your lower cost or lower volume stuff, prototypes, quick turn market, time to market type of things, and overall the higher volume stuff, which we'd like to see, definitely falls into our fixture tester options. And with that, any other closing comments for you, Rick?
No, Todd, I found this topic very interesting, especially since we know that the CHIP Act that's going on in the US here. I think we'll see more printed circuit boards being developed, even more chip carrier boards being developed in North America. I think that's all going to help the PCB industry overall, but it will take some time to filter down.
Yeah, I totally agree. And, you and I have been in this industry for a long time, 30 plus years, each of us. And we've seen flying probes from the beginning to where they've really come now. And they're definitely an adversary in there now against the fixture testers, because like we've said, they are faster. They can do a lot more than they originally were doing back in the 80s and 90s and even into the 2000s. And I think they definitely have the niche, and that will continue. So thanks,
Yeah.
Rick, for joining. Go ahead.
On that note, Todd, they can do the work, right? But even if you want a medium volume shop, you're going to have multiple of them, many of them, right? So rooms and rooms of just flying probe in order to keep up to a couple grid tester
True.
or fixture testers. So I think that we need to bring that into play too, because when you have multiple machines, there may be a little bit more of a maintenance cost overall. But
Absolutely.
yes, Todd.
Yeah, we didn't bring that up. It's not a one-to-one comparison, definitely, with a fixture tester versus a prober. And I don't know in my crystal ball what the number is if you wanted to do the same volume on a flying probe versus a fixture tester. Depends on the model of machine, how many heads and all that. But yeah, definitely, you're definitely going to have more flying probes per capita to do volume than you would for fixture testers. Absolutely. Well, from on behalf of Rick Meraw and myself, thank you for joining us on talking about high and low volume testing, the ins and outs and pros and cons. And if you want to have any more information, drop us a line at info@gardien.com. That's info@gardien.com. Visit our website at www.gardien.com and check out Buzzsprout or Apple or any of your favorite podcast venues to see our entire series. Until next time, from Rick and myself, we'll see you again.